What is up, gang? Mr. B here, bringing another sweet, wicked, awesome math video. In this video, I'm going to take you through graphing a quadratic that's in standard form using the mapping rule. And you might ask when you might need this in this particular unit, Math 200 that we're doing. That's what my students are doing. So one of the outcomes of this unit is for us to be able to find the inverse of a quadratic function. And it's really useful to have a systematic way to go about graphing a quadratic. There's lots of different ways to graph a quadratic: vertex, extra points, axis of symmetry. This is just what we're doing in this particular unit. So I'm going to take you through using a mapping rule and showing you basically a great way, a systematic way of graphing a quadratic that works every single time. If this video helps you in any way, like, share, subscribe, and without further ado, bam, into the screen. All right, so first of all, we got a quadratic here in standard form. Or you might call it general form. All depends on whatever your math teacher uses. I used to call it general form until people deciding my job decide you can't do that anymore. You got to call it standard form, so now I'm doing standard form. So remember, this thing is equal to y equals ax squared plus bx plus c. So in order to do a mapping rule, we need it in transformational form, or really for a quadratic, that is vertex form. So I'm going to change this standard form into vertex form. So we already got our a value. Our a value is 2. Now there's a couple different ways that we can actually change it into vertex form. You could do completing the square, or what I like to call is the easy way, which is to use the axis of symmetry and then plug it back in to get our y coordinate. So all we really need is the vertex. So completing the square does it, or using the axis of symmetry does it as well. So we use this formula, which is called the axis of symmetry formula, x equals negative b over 2a. We know our b value is 4, so negative 4, divided by 2, and our a value is 2. So that 2 is already in the formula. And again, that's just something you need to remember. The axis of symmetry formula, negative b over 2a. It doesn't give the x-intercepts. It gives the x-coordinate of the vertex. That's all it does. Same as the axis of symmetry. So that's negative 4 divided by 4, which ends up being negative 1. So if we have the x-coordinate of the vertex, we can always get the y-coordinate simply by plugging it back in. So y equals 2 negative 1 squared plus 4 times negative 1 plus 3. So that ends up being 2 right here, minus 4. So 2 minus 4 is negative 2, plus 3 is 1. So that gives us a vertex of negative 1, 1. So now we can go ahead with that value. Remember that this is h and k. The vertex is h and k. It's essentially the horizontal translation and the vertical translation. Well, not essentially, it is, right? So with a quadratic, we don't need the general f there. We need the actual quadratic function. So if we were going to write a general function, it might look like this. Y is equal to a f of b x minus h plus k. However, quadratics, we don't really have a horizontal stretch. That's probably a more complicated question this video is meant to ask. But just take it that the b is 1. With a quadratic, the b is always 1. This b and that b, not the same. All right? That b is the horizontal, related to the horizontal stretch. So what we're going to say is that b is always 1 for a quadratic. So essentially, we have this. X minus h plus k. So let's just take that and really ignore the b, essentially. So our quadratic is the function. So we can replace that f. We all know that a quadratic, what makes something a quadratic, is having a highest power of 2. So I'm going to take out that f, and I'm going to replace it with a squared. So this is what we call vertex form. You've probably seen this 1,000 times. You probably didn't need that explanation, but there it is. That's how it works. That's why it's transformational form, because it really follows the exact same thing that we are doing in this particular section of graphing transformations. So now that we have our a, h, and k, we can actually write the vertex form. So 2x, remember h always follows the opposite, so it's subtract -1, which is actually +1, squared plus 1. So from this, what we're going to do is we're going to write a mapping rule, and we're going to make a table, and then we're going to graph it. So the question is, what table do we actually transform? So what we do is we use what's called the base table for a quadratic. Every function has a base function. For a quadratic, it's just y is equal to x squared. So what I mean by base function is what is the most simple version of it, right? So the most simple version of a linear function would just be y is equal to x. Same thing goes for a quadratic. Y is equal to x squared. Cubic, y is equal to x3, so on and so forth, right? So we can pick the x values, but we want to pick them symmetric about the origin. So let's go 2, -1, 0, 1, 2. In general, when we have a base function, we try to at least have 5 points. You should certainly go bigger, but for the most part, when you get into the bigger x values, there's a possibility of that thing being shifted off the grid, which we don't want. So all we do with each of these numbers is run it through the equation. So we're squaring each of these numbers. So it's 4, -2 squared is 4, -1 squared is 1, 0 squared is 0, and then 1, and then 4. That's it. We're going to transform this base quadratic into our transformational vertex form. So before we do that, we need to write our mapping rule. So remember the mapping rule. xy goes to 1 over bx plus h, ay plus k. So remember that for a quadratic, the b value, that's just 1. It disappears. So it'll always just be x minus h, or x plus h, or minus 1. And then ay, so a is 2, y plus 1. So we'll transform that table using this mapping rule, all right? So I'm assuming that you have some experience with mapping rules, guys, that this is not the first time you're looking at a mapping rule. If you need some explanation of mapping rule, then this probably is not the video for you. I'm not going in depth with this. This is more for my students who are doing a unit on mapping rule, and it's useful to know how to map a quadratic to help out with another topic, inverse functions in this particular unit, right? So, but if it helps you, certainly, I hope it does. So the mapping rule is x minus 1, 2y plus 1. So all we need to do is go ahead and subtract 1 from each one of these x values. So it becomes -1. No, it doesn't. It becomes -3, -2, -1, 0, and 1. So basically, it's shifted. The x values are shifted to 1 to the left. And for the y values, I just go ahead, put them all in. So 2 times 4 is 8, plus 1 is 9. 1 times 2 is 2, plus 1 is 3. 0 times 2 is 0, and then plus 1 is 1. And we repeat. So 1 times 2, that becomes 3. And then 4 times 2 is 8, plus 1 is 9. So what you should notice about the y values for a quadratic is that you get repetition. And if you did it correct, your vertex is right here, okay? The exact same thing as what we had up this way. So now we're ready to graph. So we got -3 and 9 right up here. And then -2 and 3. -1 and 1. And then all the other points should be symmetrical about it. And there it is. And I'm just going to dot it in here now. Get like a general shape of it. I'm going to highlight those. Not the prettiest looking thing in the world there, guys, but, hopefully you get the point from that. So that is how we graph a quadratic with the mapping rule. Works every time, and in fact, this will be your table every single time. That will be your base table. So if you want to just remember that table, then you don't actually have to worry about remembering y is equal to x squared or what table do I use. You use that one for every single quadratic. If you get standard form, you always have to change the vertex form. If it's already given to you in vertex form, you're good as gold. You can go ahead and do it. But I would highly recommend using vertex form. You don't have to. But if you're doing a unit where you have to find inverses, then you're going to need that vertex form anyway. So my students are going to need that because we find the inverse of a quadratic from vertex form. That is the best way to do it. So that's why I recommend using the mapping rule, because if you already need vertex form, then the mapping rule leads from that. Just remember that there's no horizontal stretch when it comes to a quadratic. So that means really that this b is not needed and neither is this b. All right, so keep that in mind when you're doing transformations with quadratics. So I hope this helps you in some way, guys. If it does, like, share, subscribe. I really appreciate all the support that I get from my channel and from my students. Love you guys so much. Peace. Enjoy. Have a great one.
A lot of boring math later.
I like this guy's mathematicals.